Are we good to go? Yes, okay. Hi everyone. Hi, everybody still awake? Was it a long day? Okay, let's see where we can take this. Hi, I'm Philip. Let's see what we can do about monitoring and what you're doing about monitoring and maybe what you could do better about monitoring or different. Let's see. So the idea for this talk came to me basically when I saw this tweet when somebody said like, well, the monolith is nice and easy to debug, but if you have a distributed service like microservices, then it's more like a murder mystery. And maybe some of you like murder mysteries, and you really like debugging every different kind of piece, but maybe you don't want to look for so many pieces and you want to have a bigger picture of what is going on in your system. And this talk is a bit more about the bigger picture and what is going on, maybe in your application. And I have a broken application, and we can just debug and see how the broken application is doing. And we can monitor it from all the sides while you do the requests and we see how the application is doing. So oftentimes this is us, and we say like everything is fine, whereas actually everything is a bit on fire, but it's just a bit and it's working so far. And then you figure out it's no longer fine and everything is really on fire, and we kind of want to avoid that bottom half where we say what is my problem and what is wrong here and what is really the problem in my entire stack. We want to avoid that bottom half basically. That's the general idea. So let's see where we can take this. So we want to monitor all the things, and I think in the title we already have logs, pings, metrics, traces, and we want to combine all of that together to get a bigger overview of what is going on in your application. Who is already using some kind of centralized logging? Okay, that's not that many. So you've come to the right talk. Maybe we see why we want to do more of that or not so much of that. So let's see where we can take this. So who has heard or is using the ELK stack? The classic ELK stack, Elasticsearch, Logstash, Kibana. So you have Elasticsearch storing the data. That's where you store your data. Logstash is kind of like the thing that gets your data, fetches it, parses it, enriches it, and stores it. And then Kibana can visualize everything. What do I say when I say Logstash can enrich data? What might be enrichment? Because I think parsing is clear, right? We have a log line and we parse out the log level, for example, or the timestamp, so we can work with that. But what do I mean when I say enrich? Any guesses? It could be, for example, if you have an IP address, the geo-IP information. So you want to figure out from where are my visitors coming from. And that you already enrich when you store the data, so you can actually search that and say like, give me all the visitors coming from Portugal today. And then you can just filter down on that, and that would be that part of the enrichment in the process, where it's just not the raw data, but you add some additional metadata. And there will be much more metadata that we add, so we might get information about on what cloud provider is this running, or is this running on Docker or Kubernetes, or any kind of this kind of metadata we will try to fetch and enrich with our data. And this all worked fine, and then we added another component called beats, and then kind of the ELK figured out that it's an ELK B or BELK personality, and that might look something like this. And you can see it's a B and it's an ELK. And that's kind of nice for naming, but is this very scalable? What happens if we add another product? We will get another letter, and then we'll need to redo the entire branding, and we'll need to make up another animal, and it will not get easier to make up new animals, because whatever the next letter will be, it will be very hard to make up that animal. And also, if you remember Java 2EE, the recruiters are still asking for Java 2EE developers, even though that has been not the right name for more than 10 years. And we don't want to be in that position where people come with an old name all the time. So what we're trying to do is we want to have something more scalable because, well, our systems are also supposed to be scalable. And what would be much more scalable than one thing that is kind of like all the letters, we just call it now the Elastic Stack, which is much more scalable because, well, whatever products we have, we just put them in there. Maybe we have to redo some colored squares here, but otherwise it will always be the same. So when you say ELK, we will understand, but we try to call it Elasticsearch in general. That's the general idea. And this is what we want to use for logging today. So what I'm showing you is all free for the majority of the part, even proper open source. We have some source available components in there as well, but mostly it's just open source and you can go wild and do whatever you want with that. So why am I talking about that? Well, I work for Elastic, the company behind the entire product. So we are the company doing Elasticsearch, Kibana, Beat, Logstash. We have a component for APM. All of those are part of our stack. And I'll just give you a bit of an overview of what you can do with those. And maybe you might be interested in doing more with that as well. So I'm building very highly monitored Hello World applications, and today is no exception. So this is not a proper application. Your applications will be more complicated, and I can cheat. So I will just keep stuff simple to explain the concepts. And I will then show you what you can do or some stuff that you might be interested in. So let's assume this is our CEO, Shai, who also started Elasticsearch. Let's assume your CEO comes into the room and shouts like, the application is not working correctly. And you don't really know much about the application, but you want to figure out what is broken and what is going on in your application. And well, we've had enough slides and we've wasted 6 minutes or so on slides now. And we'll just skip the slides for the rest and just look at what we even have in here. So I have a small application and you can actually generate the request as well. So Xera WTF, this is where the application is living, and we'll just do everything live off AWS for now, and that is where our application is living. It has some bugs, so not everything is working, but that's kind of a feature today, because we want to see stuff being broken and stuff not working exactly like it should be. And we'll dive a bit into what is going on where and how it all ties together. So if you have your laptop or phone handy, you can go to that page, by the way, and do some requests, and we'll keep monitoring those requests and see what is going on. So we will see where requests are coming from and what you're doing. And there's one page where you can enter your name, for example, and stuff like that. So let's see what we have and what we can do. So if you've never seen it, this is Kibana. Is this kind of readable even from the back? More or less, hopefully. I hope. I can make it slightly larger, but I think this is as far as we can go, otherwise my layout will not properly work anymore. So the first thing is you have no idea what you even have running here. So imagine your boss is standing behind you and shouting and says like, nothing is working or something is broken, and you don't really know the system that well. So you want to figure out like, what do we even have running here? So the first thing I'll head over is this heart icon that's called stack monitoring. And well, this is all running on cloud, like we have our own cloud service that we're using here. So if anything is sluggish, it's probably the internet. But just to give you an idea what we have running here. So you can see we have a 4-node Elasticsearch cluster. This is the one storing all our data. You can see this is live updating, and well, we haven't stored that much data yet, but we have stored a couple of gigs of data. So 2.3 gigs of data we have collected today. And you can see I have one Kibana instance running. We have a couple of beats. We'll cover the different beats quickly. Like beats is like lightweight agent or shipper. And these are the specific ones for specific tasks. Like, for example, if you want to collect log files, you want to look into FileBeat, because that is like tailing log file. If you want to look into network data like Wireshark, you could use PacketBeat. And it's using the same base library as Wireshark. They're using the same library, libpcap. So you can just get very similar information out of those. Who is using Wireshark? Sometimes. Those are the desperate days, right? When you have no idea what is going on anymore, then you're turning to Wireshark. And kind of the idea is, Wireshark is very good at that, to give you some hints, but Wireshark is not so easy if you're in a distributed system. And we want to make it a bit easier to get a better overview of what is happening in a distributed system. So that is where PacketBeat comes in. We have AuditBeat for security events, MetricBeat for metrics, obviously, and Heartbeat to ping stuff to see if something is up or down. And then we have tracing, where we can basically tie into our application to see what is our application even up to, like performance-wise and error-wise. In Java, it's very easy. It's just a Java agent. So you just add it at runtime with -Java agent. For example, in the JavaScript ecosystem, it's more a runtime dependency that you need to have in your dependency management, and you need to instantiate correctly. I'll show you quickly how that works afterwards as well. So I'm pretty flexible. Where do you want to start? What kind of information, where should we start debugging? Or let's actually see what is working in our application. So let's head over to Xera WTF. So I'm using WTF because that's probably the right domain for any demo. Did anybody figure out why I'm using this Xera thing here, which is my Twitter handle, my GitHub account, my domain here for the demo? Did anybody figure out where that was coming from? And I can tell you that one of the hints is it has something to do with my name. Were the folks old enough to remember the beginning of the internet? Anybody remembers Rod 13? When you rotated the letters by 13? And the nice thing about Rod 13 is if you kind of like do it again, you're back at the original because, well, 26 letters in the alphabet, so you will always get back to the original. So if you take my last name and rotate the letters by 13, this is what you get. If you rotate again by 13, you will be back at my name. And it's just a coincidence that something readable comes out of that, but that's why we have this name here. So you can do in our application, you can get a name with a parameter. So for example, you can say here, hello David, because you have in the URL, we have David here. You could add your own name here in the URL, and then it should just say hello Philip. Any guesses if this will work with emojis? Well, we can try it out. We'll probably also see if that works out in the logging because we will keep that information in a structured way. So our application can handle emojis, and we'll then later on try to see if the logging also supports emojis all the way. You can get errors, so this is what shouldn't be working, and then we have a database in the background. And then we can try to access the database, but this will also fail because we have misconfigured our database today. And this is again something intentional, like something is wrong in our application. And in this talk, we will kind of look into the various things that might be wrong in our application and why stuff is not working out as expected. So, where should we start? What kind of information where would you start debugging when you don't know what is going on? Your boss is still standing behind you and shouting and says like, fix the application. Where do you start looking? Logs? Okay, let's go to the logs. That's kind of the classic approach. How do you get your logs? So we've said filebeat, and filebeat is basically tailing these log files. So if I have my application here, let me open that one, and we need the templates. What we have in filebeat here is basically you could collect a log file, a regular log file. Like if you could assume that this is just a .log file, you could just access that .log file and then see what it is doing. But to get the most value out of that, you would need to parse out, for example, the log level and the timestamp and maybe some other structured information. How would you get that information to parse it out of a log line again? Regular expression, probably. Who likes writing regular expressions? That's the Stockholm syndrome, right? Where you got so used to writing regular expressions that you just start liking it at some point. Because I'm kind of lazy. I don't like writing regular expressions so much because it's just a lot of work. But yeah, you could have your regular log line and then you could start parsing out of that. But it's kind of unnecessary work. So what I'm rather doing is I'm writing to JSON directly, so you have a structured log file. And then you can just throw that into Elasticsearch because luckily Elasticsearch also stores JSON directly, and then you're done. So I'm lazy, I'm cheating, or I'm not sure if that is cheating, but what I'm doing basically is, so you could have, I'm using logback here, so we're in the Java ecosystem, but any other ecosystem has proper log appenders. Even PHP has monolog right now and has a proper log appender to get data out of that. So what you could do is you could either write out a flat file. This is the classical log file. And in that log file, I have my log pattern. And up here, I have my log pattern. So you can see my log pattern is we have the date first, and then we have a log level, and then we have a process ID, and we have some syntax highlighting for coloring with magenta, and we have the logger, and everything is configured here. So you could write that out to a log file with .log and then parse it back. But like I said, I'm lazy. I don't want to do that. What I want to do instead is I want to write out JSON directly. And then in my log appender, I have a log appender that can write out JSON. and I just specified this is how this should look like. So these are all the things that I want to have. For example, my log level, I put into a field called log.level. And I have a service name where I have my application name, and I have a process ID. And I collect all of that in a structured format. So I don't need to do the parsing, because it's just much easier. So let's look at what that could look like. So we head over to Discover. Depending on how our Wi-Fi is doing. Okay, 40K. We're more or less alive. So, you can see in the last 15 minutes we had a couple of log events. Here we had up to 400 events. That was probably you when you were doing more requests, because suddenly it spiked and then it tailed off again. It doesn't look like anybody wrote a script to do a denial of service against my service, which is very nice of you, but you can also do that. It will just generate more logs. It's okay. Feel free to generate more requests. It's fine. And then in those here, we have all kinds of different logs here. So you can see this is actually a syslog application. And we will get Nginx access logs. And we will get all kinds of logs from our servers here. And we want to filter that down. And when I look at the configuration, what I have done here in my configuration, I have done one thing that will come in very handy. And I've added a custom field called application Java. So you could tag any application that you have running with something, and you can then easily filter down on that information. And that is what I'm doing here. For example, here, I can just say application is, oops, just one. And then it's called Java. And then you can just search for that. And instead of 2,500 hits, you will only have a subsection of those hits, because only those are the logs from your actual Java application. And then you can see only 1,300 of those are from our Java application. And you can then open those up, and you can see we have all kinds of things here. So here, the log message was calling something bad. So somebody probably called one of the methods that is calling a 500 in the background. And you can see this is the log level info. You have transaction IDs, you can see where the log is coming from. But I've also added some of that enrichment that I've mentioned in the beginning. And part of the enrichment here is you can see we have the host information. We know on what kind of operating system this is running. So this is running on the latest stable version of Ubuntu, the Bionic Beaver. You can also see that this is running on a cloud provider. So here you can see this is running on AWS in the EU West region, so in Ireland. And you can see this is the instance ID, the instance size. So you can filter all down on all of those to figure out why something is broken or how your architecture even looks like. So we are enriching all of that in our events, so you can filter down on that. And then you could say, for example, the log level. I'm only interested in the log level, actually. Let's say we have the log levels here. On the left-hand side, you can see we have lots of infos and some error messages. And I want to filter down on only the error messages, because those are maybe more interesting. And then you can open those up. So if you click the plus icon here, it will whitelist those or only filter down to those. And then you will only get a subsection once this bar here stops loading, then it will tell you these are all the errors that we have collected. Depending on how my Wi-Fi is doing, this will be, oh no, my Wi-Fi is almost dead. Let me switch to my phone. Hopefully that's better. Okay, and once this finishes loading, you will see that you will only get the errors from our application. And hopefully, 0 kilobyte is also not very good. Come on, internet, you can do this. This is the joy of a live demo. Let's go back to that one here. Okay, we're back at 10 kilobytes. Let's hope the 10 kilobytes make it through. Because you know, if the Wi-Fi doesn't work, I will just keep showing you code. because we have plenty of code to actually show you what is going on here. So while this is loading, hopefully in the background, let's take another quick look at the code here. So what we're doing here is, I'm saying this is the path of the log that I want to collect. So you can see a var log apps and anything in JSON, I will collect that. This is actually a JSON application, and I add this metadata, the application Java, which I use to filter down later on. You can also say like, hey, I know that on this system there is some stuff running that is kind of well known. And these are the so-called filebeat modules, for example. Here I say like, I know that I have Nginx running here as a reverse proxy. And I just want to get the logs of Nginx because I know those are under var log Nginx access logs. And I can just fetch those access logs from there. You can also tag the instance. So for example, here I'm adding a tag for the environment. And I think I call this production. But you could filter down on development, staging, whatever environments you have. I know that this is running on AWS Lightsail, so this is what I'm adding here. I add a nicely readable host name for the host here. This was the enrichment that I've shown you where we knew which was the operating system and which was the cloud provider that this is running on. And then I know this should be stored in Elasticsearch, and this is where this is configured. And I won't show you my credentials, but they are stored in here. Okay. And in the background, let's see. Let's give it another chance with a new browser window. Hopefully this will work out. But 3.1 kilobyte is not very good. I hope nobody is downloading any Docker containers, because this normally kills it. Come on. Maybe. Okay, so while this is loading, we will see that in the logs stuff is happening and stuff is going wrong. And before we continue, or while this is loading in the background, let's look at something else. What were the other beats that we were talking about? Like, what might be other information that might be insightful for your application? Let's say we are very desperate. Where do we go when we are desperate? There was this Wireshark thing, right? So it's called packet beat. And what we want to do with packet beat basically is we want to look at what the what is going on a network layer. This doesn't instrument the application, but this is really just like Wireshark and is listening in on the network protocol that we have running here. So for example, this one here would say like, I want to have the TCP IP information of my system. And then you could enable specific protocols. So for example, I know that DNS is running on port 53 and I want to listen in on that. I want to know what is going on with HTTP. So you can listen on port 80 and 8080. And then if MySQL is running, I want to listen in on MySQL, and TLS handshakes are also interesting. So all of those I will collect and look at. What do I do with HTTPS traffic? Any guesses? Or what is my trick around HTTPS here? I'm not really looking at HTTPS because, well, I cannot look into the encrypted traffic because, well, it's encrypted. But what I have is, I'm kind of cheating again. I have Nginx as the reverse proxy, and my reverse proxy is terminating TLS. And then the Nginx is handing over the unencrypted request to my Java application on port 8080, and I will listen in on that. So I will look into all the requests you're sending, and while your requests are HTTPS encrypted from the outside, internally they are unencrypted. That's where I will be able to see into those requests. And let's see, maybe I'm not giving up the hope here. Come on. This used to work for a while quite well. Let's see. Come on. Okay, I'll just let this sit here and load, but you probably get the idea. We're getting the raw traffic out of the network layer, and then we can see where the requests coming from, what kind of request do we have. Like we can even see latency. What we get with PacketBeat in general is we see what is the request and what is the response. We see the protocol, which might be HTTP. We might know the response code is a 200, and it took 50 milliseconds, for example, to answer your request. And all of those can be extracted and aggregated, so we can draw out some nice dashboards at the end. But this is not what it should be. Yeah, I'm trying with. I can try with my own phone now as well. I have 4G as well, but thanks for the offer. Let's see. Ah, that's actually a good point. Then I have another theory. Maybe one of my servers now died in the middle of the demo, that would be kind of unfortunate, but so it looks we can restart. That's a very good point. Thank you. Then that's a good because these requests were being proxied through the same server, but I'm using a standalone cloud service that we are running, and this seems to be up. So what we would need to do is we can bump the server because the server is dead now. But we can do that later. So I was talking about, let's finish the thing with logging. So we were having our application is Java. When we run that, we filter down from 6,000 events to 1,100. And then we were in the log level here. Now I can filter down on 50%. Now you can see we are down to 423 events. And you can also see these are all the errors that we have. So for example, here you have the proper stack trace. And there are two interesting things here. First off, we're not breaking up stack traces into individual lines, because one line of a stack trace is pretty useless. So we make sure that it's always one event. And the other thing is we have a stack hash here. The stack hash is a logback feature where we basically hash the stack trace. And one stack trace always has the same hash. So we can then aggregate and see how many unique errors are we getting in our system. Because, well, this is just a hash. And then we could do a visualization on that one to show what we have here. So what you could do is, for example, you could say, like, I want to have a bar chart on the file bit index. And I want to have that one here is the terms. And the terms I'm interested in. Sorry. This one is the count, but we want the x-axis. Let's say these are the terms we want. And this one here is, for example, the field we have, I think it's called stack hash. This one is the one I want. And then you could see these are my top 5 stack traces, and this one appeared 319 times. And then you could look and say, like, this is the first one I want to fix. So you don't have to do anything else. It's just a feature of your log appender. And right now I'm just looking at the top 5, but we could look at the top 15, and you can see this is probably the one you want to fix the most urgently because this is happening so many times, and these other ones are happening very infrequent or less frequently. So this is the one you want to look into first. And this is just a feature of the logback appender, but we can then aggregate on that. Okay. Next up, I was talking or showing a bit about the PacketBeat information. So for PacketBeat, what I wanted to show you was the HTTP requests in specific. So we have PacketBeat, we have a PacketBeat overview. So here you can see what do I even have in my system. So you could, for example, see the DNS requests, and this is a bit small. Let me make that larger. So here you can see the number of DNS requests you have in your system. But you can also see, PacketBeat overview. You can also see, for example, here, these are the kind of transactions, like that is the number of HTTP, TLS, DNS queries you have. You can see the DNS sessions and how many of them had errors. You can see how many HTTP requests we had in our system. And you can see here, for example, this is the response time we had, the 99th or 95th percentile in response times. You could see OK and error, and these are not great colors. Let me switch OK to green and error to red. And you can see most of our requests were OK, only here a lot of the requests failed, which is not good. So something is really broken in our application. You can see that HTTP is the majority of the requests or the errors that happened, and TLS here only has a few errors. You can also see like latency breakdown. So you can see 5,000 requests were very fast, but somebody had to wait 16 seconds for one request. And you might want to dive into why. And then you could dive into, for example, HTTP transactions. So you can see this here is how many HTTP transactions you were doing. And you can see overall we had 7,000 HTTP requests overall. You could see what errors we had. And for example, you could see most of you accessed David, and I did Philip, and somebody accessed critical software. And it's good that you kept something nice, because sometimes I get not so nice stuff in these requests in here, but critical software is nice. We could actually draw out, how would you figure out what were the top names that people tried to add here? We could do another visualization for that one. For example, let's go for the bar chart again. So I have FileBeat. And the x-axis, let's say, I want to have this term again. And then we had the field. I think my field was just called name. And then you can see, OK. Now in the last 15 minutes, probably because it got a bit longer, let's say, let's go back the last 30 minutes. You can see, yeah, these are the top requests we had. Yeah, and you can probably find yourself. And if we would go even further down, like my emoji should still be in there. Like emojis are supported as well. You can see here, here's the emoji that we've used before. So this was a feature that we added, I think, in version 5 or so. So the entire stack supports emojis now. You don't have to hold back on any of these. But yeah. This is what we can get out of logs. By the way, if you want to get more of an overview of the infrastructure, we have another view here which we call the infrastructure UI. This is just showing you the instances that we have. And the funny thing is, it looks like one of our instances now died because it only shows one. If we go further back in time, it shows 2, but one of our instances for some reason died. But that's probably an AWS problem. You can see, for example, here, if you had Kubernetes or Docker metadata, you would see like how those are distributed as well. Here we can just see, for example, how is the memory usage of those instances doing. And then you could say, oh, this doesn't look so good. I want to look into this one here, and I want to either view the logs of this instance or the metrics. So for example, if you look into the metrics of that one, you can see this is the general overview of how the system is doing. You can see CPU usage over time on that instance. You can see load, memory usage, network traffic. And then, since Nginx is supported here as well, and Nginx is running on that instance, you can see how many requests we're getting through Nginx on that instance here. And how many active connections, requests per connections, etc. So you can monitor that instance very nicely here. And then you could go back, for example, and say like, OK, now I want to see the logs of that instance. That is another view here. This is more like a tail F view. So what you could do is you could just turn on live streaming, and you can see these are the requests that people are doing. And I assume, OK, you're doing the generate. This would try to generate 50,000 database records. So I'm not surprised that my instance died. But this is the joy of a live demo. And OK, you're counting up here, but this size parameter here tells it to generate 50,000 events. This is not generating an ID with 50,000. This is 50,000 database entries you're trying to insert here. So I assume my database died by now. But you can just see all the stuff that is happening here on that specific instance. So for example, here you see we're just filtering down just on the front-end application. But we could just throw that away and say, like, I'm only interested in what my Java application is doing. And I can filter down on that one. And then you would basically see the stack trace of our Java application scrolling by. Like, you could go up and just see what has happened before. But you can also scroll down and see, okay, here, for example, we have timeouts of our gateway because our server is now overloaded. And you can just watch it, how it's behaving. And somebody's trying to search something or adding a user with a specific name or just adding a generic user, and you can just see what is happening in your application. So this is really just like tail F, but you can nicely filter it, and it's centralized. And you can tie into any kind of metadata that we have here. Okay. Since we have been talking a lot about what is up and what is down, we also have some view that is called Uptime. That is the heartbeat component that can just ping the service that is available, but it looks like my service is pretty much died in the last 10 minutes. So let's go back and say, like, let's go back 60 minutes. And then you can see what different systems you're pinging here and how they are behaving. Or you could, for example, say, like, I want to have the view of today. And you could see, for example, I have one system that is currently up and 6 that are down and 7 that we're watching in total. And you can see these are all the endpoints that I'm watching. So for example, you can see I'm watching the health endpoint of my Java application here. And I'm watching Kibana and Elasticsearch, etc. So this way, it would be very easy to see what is up and what is down. And you can see once we started doing bad stuff now, suddenly my application started to die. So this uptime is very helpful to see what is breaking and what is not breaking. Something else that might be hard to show now, let's see if that is still going on. Okay, my application died for whatever reason, so we cannot reach that. But for example, there are metrics or health endpoints. What might be an interesting metric of a Java application? Yeah, let's go for the heap. Since our application is down right now, we might have to go a bit more into the historic data, like an hour ago, but I will be able to show that to you. So, if you want to visualize something, you could build a nice visualization, and we have a tool called Visual Builder, and that's more to explore your data and see what is going on. So the first thing is, so for example, we have the health endpoint that we're using here, and the health endpoint exposes a lot of metrics either via JSON or by JMX. And we can collect both of those. So what I have in metric beat, just to show you some code again, what we have, we can collect some system metrics. This was what I've shown you before, like how the system is behaving. We can also get like metadata from applications like Nginx or MySQL, but we can also tie into the JSON endpoints that here, this is Spring Boot. Here, for example, we get the JVM memory committed from the Spring Boot 2 endpoint to get those. Or if you're more a JMX person, you can tie into JMX. And you can see here we're collecting the JMX information from the garbage collection or the memory usage that we have. And we just use Jolokia here to collect that kind of information. And we store that in Elasticsearch as well. So what we can do is, let's say we want to show the heap usage in percent, okay? Because that might be relevant. Like the absolute number is not so relevant, but let's say the heap usage in percent is okay. So what we want to have is, at first I take the average of and we have Jolokia, and we're in the wrong index, so let me switch over. This is not file data, this is metric data. Metric. So let's switch over to the metric beat. Oops. Metric beat data. And what I want to say now is I want the average of Jolokia and heap usage used. And now you can see here my server was overloaded for some reason. I don't know why, but here it was available again. And what you can see is we have a heap usage of some high number, but this is not actually a high number that you want to show. What Jolokia is showing you here is this is bytes. So let me switch that to bytes, and then you can see now we have 140 or 160 megabytes of heap usage. But that doesn't tell us much because we don't know how large the heap in total is. If we have a 170 megabyte heap, this might be a problem, or 100, let's say a 200 megabyte heap. If we have a 1 gigabyte heap, this is still fine because we're just using a subset of the available heap. How do we calculate the percentage then? Well, let's see. So we have here, I have the average. I add another metric to be calculated in here. This is the maximum, and luckily we extract that in Jolokia heap usage max. And now it is replaced, and you can see my total heap is 371 megabytes. Only how do I do the calculation? Because now I have two metrics, and one has basically replaced the other. So what you want to do is you want to add a third step here, and you can do a calculation, which is like this. And then basically you say, I have this average value, this I call the average, and then I take the maximum value. And then I can just do a calculation, and I can access those variables with average divided by params.max. So what I'm doing here is I'm taking that average value, I stuff it into my variable average, and then I access that average variable with params.average here. And I do the same for maximum. So I have calculated the average usage divided by the maximum usage. And then you can see here, now we have an actual calculation of how that looks like. But this is not bytes because now we have 0.4 bytes. This doesn't make any sense. Now we need to switch this again and say, oops, this is this one here. This is not bytes, but this is a percentage value. And then you can see we are using 30-something% of our heap. And that is working fine. And for example, now you could add one more thing here and say, like, I want this to be broken up per host. So for example, I say, like, here I have a host.name, if I remember correctly. And now it will tell me, oh, this is the front-end instance. So if you have multiple instances, it would show you for every single instance how much of the percentage of your heap are you using in your application now. And you could, since my application is down right now, it doesn't show so much, but we could, for example, say, like, I want to go back by 3 hours ago. And then you can see that our application, it doesn't really look like a memory leak. Like, this was when you started doing more requests, then you started killing my application. Now it seems to have recovered for a bit, but now it's dead again. But you can see how the heap usage is generally okay-ish here. One other thing that you might run into every now and then is that you run around the office and shout, who did something? Because something changed in your application, right? How could you avoid that? So since I roll out everything in a structured way, I'm using Ansible here, we could actually add an annotation that says, like, something changed, like you deployed a new version of your application. And you can do that here as well. So in annotations, I can say, like, I have some data, you need to, like, my automation system is storing an event in Elasticsearch to show me how that is working out. And just to give you a quick idea how that looks like, and also because I always forget which fields I have in that event, we have, so what we want to do is we want to see which indices do we have in Elasticsearch. And the one I'm interested in is called something with events. Oops. Events. Okay, this is the index I want. And then you can take the events index. This is basically a select all from a relational database. And what you get in here, you can see this is basically Ansible did something, and it ran a script configure all on that instance. And later on, we see this is a deployment thing. So here we ran a deployment step where the user Philip deployed the backend, or on the backend application, ran some script here. So we maybe use application users host. Let's do that. So what we do is we have the event index. We want to use the fields application user host, user comma host, and then I can say user changed application on host. And if it did everything correctly, and this refreshes correctly, then we can also say like this should not be, I don't know, let's say this is, let's annotate this with a bug. And we are in the events. Obviously, if you type the wrong index name, it will not work. If you tag the events index name, then you can see Philip changed deploy on that backend instance. And this way you have annotated, you deployed something, for example, or you changed some configuration, and you know exactly who did it and where to complain now. So you don't have to run around the office anymore for that. And that will be very helpful when suddenly something changed in your application. Okay, we've seen pings, we've collected all kinds of information. We maybe want to look into tracing as well. So what we do with tracing is we have written our final application, and when I deploy it, sorry, this is, let's go for this one, the backend configuration. So for example, here I have, this is how I instrument my application. So you can see here I've defined my heap usage, I define where my services are and where my database is. And then here, this is my tracing. So we have an agent for tracing or APM, application performance monitoring, where I basically say like hook into the application, but only link this jar through a Java agent and look what is happening in the application. And that then looks like this. So it figures out we have a front-end and a back-end application. It would even know if you, or this works across various programming languages. So for example, we could just look into the front-end application. Let's say we want the last, 2 hours. Because this is when you started doing your request. Or actually, we could zoom into that one here as well. So I can just mark the relevant area, and now we can jump into that. And you can see which response codes did come out of your application. You can see what was the average duration of the response times from your application. You can see which controllers were called in your application. And we could see, for example, here, this one was called 16 times per minute. And it took, on average, 180 seconds to respond, which is not very fast. So you might want to look into that. So you could just click on that one, and you would see like these are all the calls that you have. You can see these are like how long did these requests take on average. Like here you could pick like this was the slowest request that took 1,400 seconds. And I'm amazed it took even that long. Well, somebody tried to add David, but well, it was just overloaded. And you could see like these are the calls, like what is even being called. Like here you could see this was calling the add method. And you can see this is in the class frontend controller add in line 64. This is basically where this is going. And then you have the library frames. This is basically the Spring Boot application or the framework that you're using. So this one here will only show you your own code because normally the problems are in your own code. So you could see those first. You could, of course, then dive into that, but this is just what Spring Boot is doing, and this is not what our problem is today. So you could see this was the HTTP request, and these were all the headers that you sent. So for example, I see it was probably somebody from Portugal because the language was Portuguese that you asked for. We can see all the headers. We can see which hosts and services were targeted. We can see, for example, which Java version I'm running here. You could see this is the Java version I'm running against that one. This is the URL that you hit, so you asked for David. The port, the name, everything like that can be in here. If you had Spring Boot, for example, you could integrate the user management here and you could see which users are doing the requests. And that way you could both dive into like just specific errors or just slow requests and start finding what they are doing. Or you could just go out a bit again and see like these are all the requests that people are calling. And for example, our backend application unfortunately has the error. So if I head back to the APM overview, my backend application here, you can see this was also doing a couple of requests, and you could dive, for example, into add new person. And here you could then see these were the requests that people were doing on the add person. If I scroll down here, you can see these are all the methods that you're calling. So these are all the methods in your code. And you could even see down to the SQL statement, whatever your SQL statement was that you were trying to access here. And that will make your life for debugging much easier. Okay, so since we're running short of time, I hope you've seen some of the options that you can use. I always compare this a bit to Lego. It's not a solution that you buy and just use. It's more like how you assemble that and what makes sense for your use case is something you will need to figure out yourself. But it's a good opportunity to combine like logs and then metrics and traces and health checks where you ping your application. You can put all of that together, and you just need to stack the right Lego pieces together. We've looked at a lot of these, like, I've skipped the security events, but otherwise we saw system and application metrics, and we saw logs. We looked into the availability of our service. We saw the application metrics where we looked into the JMX heap, for example. We looked into tracing where we saw these were the requests and this was what was happening behind the scenes. If you want to try that out yourself, we have a complete repository where you can run this either on AWS, or there's also a Docker Compose version where you just do Docker Compose up, and it will download half the internet and then run it for you. But that way you can just try that out yourself. And by the way, we do support a lot of languages. So for example, if you want to use that with front-end JavaScript, this is how you would tie into your JavaScript application there. We have agents for Python, Ruby, Go, Java, soon.NET, Node, React, and we can tie into all of those and get the traces for those out. Cool. And yeah, this is probably the most important URL. If you want to try that out, this is where you can get all the code and the samples. And that's pretty much it. I have a couple of stickers over here. If you want stickers, take stickers. So, well, you can decorate your laptops or your coworkers or your kids with them. If there are any questions, since we're out of time, just come to me and find me afterwards. I'm happy to answer. And I'm always trying to take a picture with you so I can prove to my colleagues that I've been working. Because we're a fully distributed company. Like, people don't know where I am today. So, wave. Thank you. Thanks a lot.